Hello, and welcome to the next segment 6 of video training overview of hyperspectral imaging technology. In this presentation, I will go over airborne integration. These are the integration factors. Consider weight, size, and power, frame rate versus altitude, speed, and IFOV, data storage capacity versus flight time, mechanical integration, such as mount, wiring, antennas, GPS and IMU accuracy, the digital elevation model, orthorectification software and accuracy, calibration integration, focus adjustment, frame rate versus altitude, speed, and IFOV. Proper imaging requires matching IFOV and frame rate. So frame rate too slow, maybe smeared images. Frame rate too fast, wasted storage space. Ideal frame rate equation. Frame rate in hertz equal UAV speed, millisecond, and IFOV, meter. Is a frame rate formulas you could use to calculate the proper imaging requires. Here we have a field of view and spectrum stitching. So you have the angular FOV will not overlap when spectrometers are starting NIDAR. Altitude will play a role when co-bore sighting. Geospatial offset between spectrometer by several pixels. Altitude speed along with FOV will drive frame capture speed. Here we have the GPS and IMU accuracy. So GPS measure position of sensor relative to Earth and sea level. IMU or INS measure acceleration and angular changes. So high accuracy GPS and IMU improves result up to a point. Avoid having IMU resolution more than 10 times larger than sensors AIFOV. Here we have the orientation of the how the GPS and IMU mounting on of our sensor. Then we have the mechanical integration. So sensor may need vibration isolation, gimbal mount, mount GPS IMU securely to sensor, if possible mount along sensor optics axis. Here we have the orthorectification accuracy. So the orthorectification transforms the central projection of the photograph into the orthogonal view of the ground. So removing distortion effects of tilt and terrain relief. The result of this process is data outlined on a scale that is constant, allowing for accurate measurement when calculating distance and directions. There's factors affecting accuracy. Notice that elevation is an important factor in accuracy. Not only is there's distortion, but there's also a remapping based on how far off the elevation is from the ideal elevation. As you can see on the in the diagram, the mesh above and the blue square above. Lesson learned. When you have an issue, first you want to check sensors flying perpendicular to the slit length, sources of EMI noise that could be affecting the IMU and GPS or the sensor itself. have a clear wiring diagram, mechanical drawing of all the parts with which the sensor will be connecting. That's very helpful. This will conclude this presentation. Stay tuned for the next segment 7, overview of hyperspectral imaging technology. Thank you for watching.